NASA is using the lessons learned from Ingenuity to create a next-generation Mars helicopter. It will be capable of broader scientific exploration and operational support. This new design moves from a technology demonstrator to a fully functional science platform. This will enable more ambitious missions on the Red Planet. Key improvements in enhanced flight systems. Larger rotor blades generate more lift in Mars' thin atmosphere, which has a density of less than 1% that of Earth's. High-efficiency electric motors will produce more power for higher altitudes and longer flights. New solar-powered batteries that will store more energy, enabling flights spanning several kilometers and lasting over 10 minutes. Key improvements in autonomous navigation. Improved AI for terrain analysis, obstacle avoidance, and real-time decision-making. Enhanced ability to identify safe landing zones, even in rough terrains. 3D terrain mapping with onboard LiDAR and stereoscopic imaging for creating detailed topographical maps. Key improvements in scientific instrument payload. The helicopter will carry advanced instruments for in-depth scientific investigation. Spectrometers to help identify mineral compositions and detect organic compounds. Environmental sensors to measure atmospheric pressure, temperature, and wind dynamics. Ground-penetrating radar to study the structure of what is under Mars' surface. Key improvements in structural enhancements. Lightweight frame constructed from advanced carbon composites to increase durability while reducing mass. Improved sealing and materials to resist the pervasive Martian dust, which can affect mechanical and electronic systems. Enhanced insulation to protect against extreme temperature fluctuations, which can range from -80 degrees Celsius to 20 degrees Celsius. Operational capabilities include increased autonomy. The new helicopter will operate independently. Real-time support for mission control will not be possible because of the communication delay between Earth and Mars, which can be as long as 22 minutes one way. It will use cutting-edge computing to process data on board, enabling faster responses to environmental changes and mission objectives. Operational capabilities include support for rovers and landers, identifying areas of interest for rovers, including the safest paths and most scientifically valuable targets, assisting in recovering cached samples for future Mars sample return missions, detecting obstacles like boulders, sand traps, or cliffs that could impede rover missions. Operational capabilities include independent exploration, flying into regions inaccessible to rovers, cliffs and canyon walls, deep craters or rugged terrains, possible caves or lava tubes, which would be the most likely place to find evidence of life. Scientific applications. The new helicopter's capabilities will significantly enhance Mars exploration. Improved geological studies through high-resolution imaging and spectroscopy will help study rock formations, identify water or ice deposits, and analyze sediment layers. Improved atmospheric research by measuring wind patterns, dust behavior, and temperature gradients to understand Mars' climate. Searching for signs of life by identifying organic molecules or potential biosignatures in unexplored regions. Creating detailed maps for planning future human and robotic missions. Ingenuity has laid the foundation for this new design. Proven flight dynamics that demonstrated the feasibility of powered flight in Mars' thin atmosphere with over 50 successful flights. Ingenuity survived months beyond its expected lifespan, providing valuable data on Martian environmental challenges. Ingenuity demonstrated areas for improvement, including navigation precision, endurance, and payload capacity. The upgraded helicopter may be included in NASA's Mars sample return program, assisting in retrieving sample tubes for transfer to Earth. It is also being considered for Mars Ice Mapper missions that explore subsurface ice deposits that could support future human colonization. This helicopter design will serve as a prototype for aerial exploration on other celestial bodies. Saturn's moon Titan, with its thick atmosphere, with NASA's Dragonfly rotorcraft, is set to fly in the 2030s. through future concepts for aerial platforms to explore the dense atmosphere of Venus, supporting human missions by providing reconnaissance and environmental data for astronauts, potentially making Mars exploration safer and more efficient. Technologies developed for this helicopter could inspire international partnerships for advanced space exploration. In conclusion, the new Mars helicopter design reflects humanity's growing ambition to explore and understand the red planet. It signifies a leap forward in aerial planetary exploration, bridging the gap between surface rovers and orbital spacecraft, and paving the way for even more innovative missions in the future.